Good Wednesday morning to you. Roger Hill, Wuthering Heights. We're looking at a wide shot here of infrared satellite picture, looking at North America, and you can see Eastern Asia, all of the North Pacific Ocean here. This is the intertropical convergence zone, roughly about 10 degrees north latitude, where the convergence of the trade winds produces usually a band of showers and thunderstorms. You can see it up with the satellite picture here. This is also very strong El Nino right now, really basin-wide, all the way from the central and across the eastern Pacific, and one of the wider El Ninos we've ever seen. Temperature anomalies also above normal off the coast of Baja and off the coast of California, and maybe having some effect here. But what I want to show you here is what we call an atmospheric river. The one you've probably been hearing about is moisture that comes in sort of a daisy chain of storm systems that tracks all the way across the central and even from the western Pacific, then into the eastern Pacific, coming ashore from Northern California to British Columbia. This is kind of ground zero. They're getting pummeled by some pretty exceptional shots of rain, and the water vapor imagery shows it better actually, where you're looking at a lot of moisture peeling off here from the intertropical convergence zone way out across the eastern Indian Ocean and the western Pacific. Another atmospheric river that's very evident here starts sort of southeast of Hawaii and peels off the intertropical convergence zone, the ICTZ, and takes a little bit south of Florida. This is basically the subtropical jet stream that we talk about that is so common with the strong El Nino. It's a little bit suppressed to the south, this one a little bit suppressed to the north, and it could be that we have sea surface temperatures interacting with that, and it's just not quite set up as you normally find it. Needless to say, check this atmospheric river. It goes all the way across the central Atlantic into the eastern Atlantic and into Europe and Scandinavia and eventually the Arctic Ocean up north of Finland and toward the Kara Sea. Pretty amazing stuff to see a line, a daisy chain, if you will, of storm systems tracking like this, as well as a daisy chain of storm systems across the Pacific Ocean slamming the west coast. What does that do for the northeast United States? The generality is that it makes us warmer. Geopotential heights are leaning toward high pressure rather than low pressure systems. We do have one that's going to come across tomorrow morning. It could bring us a little bit of a spotty freezing rain aspect, although the temperatures will be above normal. The air temperatures, the ground temperatures will not, and that's where conditions get a little bit tricky. So watch it for the drive tomorrow morning. Notice the storm, several of them. 1, 2, 3. The fourth one is kind of the penetrating storm system. The leftovers running into the general higher heights of higher pressure and weakening as it does. So these systems come ashore and really unload on the west coast. This is good, very drought-ridden. No ridiculously resilient ridge going on now. A little bit of something potentially here with the sea surface temperatures being warmer than normal, and this sort of split with another atmospheric river working its way into Western Europe. And it starts in the eastern Pacific. One other quick thing to look at with the atmospheric river aspect. Again, this is North America, South America. This is the intertropical convergence zone. Heavy-duty precipitable waters, of course, very big moisture plumes here associated near the equator. Okay, we got that. However, look how this gets peeled off. And this is the atmospheric river. You can see the thin line as it works in the Pacific Northwest. Pretty amazing. And then the other one that works across northern Mexico, you can see that headed for Europe. Roger Hill, Wuthering Heights.